All right. So this is our third meeting. We are looking at assignments, arithmetic expressions, etc. So the lab and the class exercise both will focus on those concepts. And the next assignment also would be covering that topic. So let me go ahead and say a few things about the next assignment. It is also there on the video, but I wanted to emphasize that. Before I start doing that, I wanted to know if you have any questions on anything that was on the lecture videos or PowerPoint.
I didn't understand that. Wait, just 1 second, mister.
Sorry?
Yes, just 1 second, please. I didn't understand the floor division very well.
Which video?
No, the floor division.
Oh, the division.
The floor division.
Oh, okay. There are two types of divisions. That's what you're talking about, right?
Yep.
Okay. I will explain that. Let me go ahead and share my whiteboard with you.
Mm-hmm.
Okay. Give me a second. So there are two types of divisions. One is 2 slashes, the other one has just 1 slash. This is what you're talking about, right?
Yes, the floor division. Yeah.
Okay. Suppose I have the following variables: a equals 5, b equals 2, and I write c equals a divided by b. So I'm using this single slash. This divides 5, a is 5, right? So a is 5, b is 2. So 5 is divided by 2, and the answer is 2.5. So C would now be 2.5. Okay. On the other hand, if you write C equals, or maybe D perhaps, D equals A slash B, then this will divide A by B. Of course, division is still taking place, but 2 goes into 5 2 times. The fraction is ignored, and D is now 2. So this is actually integer division.
Oh, so you always ignore the fraction?
Correct.
Oh, I see.
Yeah. But there is one little catch to this whole thing. Let me clear, let me see if I have some space here, or maybe I'll get rid of some of these. I need some more space. Okay, so I'm going to give you one more example, which is also covered, I think, by one of the problems in the class exercise. If you have A, maybe not A, let's say we have P equals, let me put 5.0, and write C equals P divided by B. So P is 5.0, sorry, P slash B. That's what I want. All right, P slash B. P is 5.0, B is 2, okay, as before. Then this will actually be not the 2 as an integer, but it will be 2.0. Because this P is 5.0, it brings that decimal point over here. Okay. Or it doesn't really matter whether it is 5.0 or 5.3 or 5.5. It would be 2.0 no matter what, because this has a fractional part in it. So Python goes and puts that decimal point into C. So this is a float value. Okay.
Mr. Brahma, could you also do the modulo or whatever
Yeah,
the
sure, sure.
name is?
Yeah, sure. Let's clear all this stuff. The mod operator is percent. Once again, let's take some numbers. A equals, let's say 9, B equals 4. Then you suppose we write A percent B. Then A is 9, B is 4. So B goes into A twice. So we have, maybe not. Let me show this 9 little things here, okay? I'm just trying to make it, giving you a different viewpoint. So there are 9 things in A, right? And B is 4. So if you divide A by B, we are doing mod operator, right? This is mod. This will work like this. Suppose we divide A by B, B goes into A twice, 2 times. Integer, 2. So those 2 things will take care of these many things. Because B is 4, so the first one of these 2 will take care of 4 of the 9 things. The second one will take care of the next 4. So we are left with 1. And that is the value of C. So this is the remainder. This is a simplistic view of the whole thing. For the moment, or maybe for most of this course, let's assume that A and B are both integers and are positive. There is a more elaborate definition of what percent does, but I don't think it is something we should be worrying about. I can explain it if you want, but it is a little more complicated.
Just what would be the purpose of a Modelo?
Yeah, go ahead.
Yeah, what would be the purpose of the Modelo? Why would you want to find the remainder? Like, what would be the application of that?
Okay, there are many applications where we want to get a number between a certain range. So let me show you one huge application in the IT world. Suppose you want to store, I mean, it actually has too many applications. Suppose you want to store data, right? So we are all in this university, our data is stored inside the computer systems. So one way of storing the data is actually in a table. Okay, so you can have a table, and your data can be in the first entry, I can be in the second entry, the third person can be the third entry, etc., etc. And it so happens in the computer world, these table entries are denoted by numbers starting at 0, 1, 2, 3, 4, 5, 6, 7. So this is, of course, a very small table that has only 8 entries. And the entries are numbered 0, 1, 2, 3, 4, 5, 6, 7. So given your info, perhaps your name, social security number, your address, phone number, etc., I would like to find a good location for you here. Okay, so I will process your information, maybe your name. And using your name, I will get a number between 0 and 7. So how do I do that? Suppose your name is John. then you must have seen a video where it says all these characters have corresponding code points or numbers, right? Do you remember that stuff?
Yeah.
Yeah, okay. I don't remember what the number for J is or O is. None of these I remember. Let's assume, let's pretend, okay? This is not right, but most probably not right. Let's say J is 70, O is 100, H, okay. You can't argue with me on this one, right? Don't point out later that this is wrong. I know these are not right. It doesn't really matter, okay? So we find all those numbers, add them up, and how much do they come to? 349, it looks like. Okay, so if you add up all the code points corresponding to your name, which I am assuming is John, we get a number like this. It won't be 349, I know that. And then I need to convert this to a number between 0 and 7. And what I would then do is do a mod with 8. This is called hashing, which you will learn in computer science in a later course, in later courses actually. So what would this be? This goes in 43 times and the remainder is 5. And so I will put John's info here. Okay. Then if Mary comes along, maybe Mary's name, when I hash or when I add up all the code points, might give me, let's say 500. Let's pretend it is 500. And if I do a mod with 8, this is going to give you 62. Give me a second. Yeah, I think it is going to give you 4. The mod would be 4 because this will go in 62 times and the remainder will be 4. So Mary will be stored here. Mary's information will be stored here. So we are dividing, or rather we are doing a mod with 8 so that we will get a number between 0 and 7. The remainder will always be between 0 and 7. Of course, more than one person could be stored in the same place. There are ways of accommodating more than one person. We are not going to get into all that. So hashing is a process done for more than one reason. Hashing is also done when you transmit your messages on a network. For example, if you are paying with your credit card for a purchase on an online store, then the information you send out might be hashed. There are security protocols that use hashing. So hashing often uses this %. So that would be one place where you would be using it. It can also be used for other kinds of applications. I think I mentioned something like assigning people to projects. If you have so many people and so many projects, how many people are left over after you assign everybody equally? That is probably a little contrived example, but there are similar kinds of things. In fact, there is, if you look at one of the examples in the D12 site, given something like 300, suppose you have a number like 343, and suppose that is number of cents that you have to come up, and you have to come up with the minimum number of coins that make up these many cents. Then you can actually use % to take care of that. There is an example that uses it. I suggest that you take a look at that. Does that give you some sense as to what %?
Yeah.
Yeah, okay. It has huge applications, actually, yeah. Okay. Any other questions? All right, let me go ahead and show you the assignment. I wanted to show you the next assignment. There is actually this document is available on the web, and then it is also explained a little bit. I mean, not the problem, but some aspects of the submission. So what I want you to do is not lose points for fairly simple things. For example, the file that you submit would be a Python source program. At the very top, you should put your name in a format like this. You should write author and give your complete name. Then you should write what the program does. You can actually get a description of the program from here and adapt this. So stuff like this here. This essentially describes the problem. You can copy it. You can massage that a little bit. You should not be copying that and pasting it verbatim. It wouldn't make much sense and it is not right. So you should adapt that a little bit. It will take you maybe a couple of minutes to do these things. Don't lose points for that, because you can easily get those 3 points here. Then you should write your pseudocode first and then only write the Python program. Don't do it in the reverse order. Don't write your Python program and then copy and paste it and maybe massage it a little bit and then say, that is my pseudocode. You are not going to get a lot of credit for that. You should write your sample test data in a format like this. The program asks for the temperature reading in Fahrenheit, and the output is the corresponding Celsius value and value in Kelvin scale. So many of you may not know how this is converted, and that I would ask you to find out from the internet. If you just Google how to convert from Fahrenheit to Celsius or Kelvin, you should immediately see the formula, use that. The reason I did not want to write it here is I didn't want to spoon feed. I wanted you to be in the habit of looking for solutions, discovering those from resources other than your instructor, because that is a habit, that is a skill that you need to develop. You have to learn continuously. So this is one of the things that will prompt you to find out things for yourself. You see, I graduated with a degree in computer science a long time ago, and most of the things I teach now, most of them, 90% or more, are things that I did not learn in my educational programs, because things have changed so much. So you will have to learn new things if you are in this field. This is not like many other fields where things change less frequently, right? So you need to develop that skill. So I'm trying to get you to do that. It's a very simple thing to Google that and get the information. And then make sure that you write your pseudocode properly. And notice that there is a table here, which was in the lab last week, which is also in the lab this week, handouts. These are just examples. If you're inputting an integer into X, then this is the code. But you may not be reading into X. You may be reading into some other variable. Then you have to adjust this. Your prompt may be not to read just an integer, but to read something more specific, in which case you should prompt for that. So take care of these things. These are just patterns that you need to adapt. Finally, starting with the third assignment, I am going to insist that all the identifiers you use are meaningful. You don't want to use identifiers like A, B, C, P, Q, and all that. I'm going to look for proper identifiers in assignments and to great extent in the labs as well. In the assignments, all identifiers must be consisting of whole words. If you have multiple words in an identifier, they should be separated by an underscore. Begin your identifiers with a letter. All letters should be in lowercase, and they should make sense. If you are reading in the temperature, it can be called temperature, but don't call it temp. Don't call it T. Don't call it with a name that doesn't make any sense. That is true for assignments, and mostly the same kind of requirements will be for labs as well. No line should be more than 80 characters wide. If you are typing into idle and you find that you are pushing beyond that boundary, you should split into a second line. The video tells you how to do that. Don't put unnecessary blank lines here and there, which makes it somewhat difficult to see where the code is. It is just distracting. Then tokens should be separated properly with spaces. For example, look at how I have put spaces here. If you have an expression like this, before and after plus, put a space. Before and after star, put a space. Before and after minus, put a space, etc., etc. Don't put a space after the left parentheses or before the right parentheses. Before the left parentheses, you would put a space if you have an operator, right? Because after an operator, you should always have a space. So whether it is left parentheses or not, you have to put that space. So follow these conventions. If even one violation of any one of these things, these are easy things to get points for. Even one violation, you lose the 0.5 points for that. So even if one identifier is not meaningful, you will lose half a point. Even if one line is more than 80 characters, you will lose half a point. If you put unnecessary blank lines, you will get 0.5 points. And if you don't indent proper, if you don't put spacing properly, you will lose 0.5 points. So I think 5 points are easy to get. 3 points here and 2 points for these. All you need is to take some care, and in the process of getting those 5 points, you will learn good programming habits. Okay, that is extremely important. In many walks of life, it is not enough to get the job done. You have to do it properly. And this business of programming is so difficult that you don't want to add to the difficulty by making your programs hard to read, hard to understand, for not only for others, but also for you.
I have a question.
Yes.
So you want us to convert Fahrenheit into Celsius and Kelvin, or is it going to be like a separate?
I want you to convert from Fahrenheit to Celsius, but I didn't get the last part of your question.
Celsius, what about Kelvin?
You have to convert that to Kelvin too. Yes.
From Fahrenheit to Kelvin, right?
Yes. It doesn't really matter because what you are reading is supposed to be in Fahrenheit. So you will put the corresponding temperature value in Kelvin as well as Celsius. Yes. Okay.
Professor Dayton,
Yes.
you mentioned that students can get this information like online. Is there a point where when you take information online, do you need to cite that information if you're going to be using more than the necessary?
Yeah, right. If you are, yeah, in this case, of course, the formula is formula. There is nothing that is so that they are universal. I don't think anybody owes owes copyright to those kinds of things. But if you are doing more than that, right, Rose? I mean, if you are using some text verbatim from the internet, then you have to cite the source, yes. But if it is just the formula, I don't really care too much. But if you want to convince me that you believe your formula is correct, you might want to cite the source. Otherwise, I am assuming that you are reading that document and understanding it, and that formula is a formula. I'm not too worried about quoting. In this case, I mean, in this particular case, because it is so universal, right? But as Rose mentioned, if you are doing more than that, if your documentation is going to include stuff that are really copyrighted, like some sentences from Wikipedia about Kelvin, the Kelvin scale, then you have to quote, you have to cite the source, yes. Yeah, it is important to not claim somebody else's work as yours. That is not done. But a formula, you know, I am assuming that you learned the formula from it. There is no need to quote the formula from where you found the formula. No, that is not important to me.
Thank you.
Yeah, any other questions? Okay. The other thing is, we have had 2 classes so far. There have been all kinds of questions about assignment, submission, and labs. People were not, sometimes they missed the deadlines, and they mistook the quiz. I mean, there were all kinds of misunderstandings about stuff. Now I think we are kind of settling into a pattern, and from today onwards, if you don't submit things on time, for example, the class exercise or the lab, you will have to use your allowance points for getting an extension, because or if you don't turn on your video for class exercise or during the lab, then you don't get credit for that work. So I'm going to insist on your following the directions in the syllabus regarding the submission of assignments or labs or class exercises, or using or turning on the video and audio during the labs, etc. So there will be no exceptions. You can use your allowance points if you want to for those kinds of exemptions, but you only have 2 allowances for the entire semester. Then otherwise it wouldn't be fair, you know. I mean, I can't keep on making allowances, because then there is no end to, it is a Pandora's box. There is no end to doing it. And I can't give an allowance for one person and then exemption for one person and then not do it for the others. So I have to be fair to everybody, right? So please understand that. And today I will do another thing. The class exercise is due only at 8, but I don't think it is going to be that long. So I'm going to close the breakout rooms for class exercise at 7:45 and create individual rooms for the labs, so that those who need have more time for the lab from 7:45 all the way till 9:20. So you'll have more like an hour and 30 minutes or so, or more than that. So what I want you to do is, if you finish your class exercise, submit that by 7:45. And the latest time that I accept is 8 o'clock. After that, no submissions. But if you don't finish your class exercise by 7:45, you can be in your individual breakout room and continue with the class exercise until 8 p.m. and then submit it. Okay.
Professor, can I ask about the lab? I
Yes.
see that the lab is online even 6 hours before we begin the class. Can we do the lab before the class, or we have to do after the class exercise?
You can do it before class and bring the solution, but I or Rose will ask you questions about the work.
Okay.
I mean, unless we are sure that you have understood the solution, a student has understood the solution, we will not be giving credit. So, yeah.
Okay.
I post the lab early so that people can take a look at that stuff, but we also want you to learn from it.
Okay.
Yeah.
Thank you.
Yeah. Some people take more time for some of these things. I, for example, take a lot of time to do my work, you know. So I also want to give you that opportunity for.
If we finish early, can we leave?
Yes, that was another good point. The moment you finish, after you have submitted, you don't have to come to the main room. You don't have to tell me, you can just leave. Yeah. Thank you for bringing up that point. I was going to miss that. Yeah. Anything else? If not, I'm going to close this session. I'm going to stop recording right now, and I'm going to start the breakout rooms. Okay.